So today we are going to discuss about a topic called monotonicity. Mono, monotonicity, and Maxima-Minima. It will be a new lecture series of functions. Okay, of functions. So basically, what is monotonicity? Let us understand that in calculus we study functions for different aims. We have already learned about continuity, discontinuity, differentiability, and non-differentiability of the function. One of the most important tools in analyzing the functions is their monotonic behavior. Functions like fx is equal to 2x plus 3, gx. Let us say the examples as these functions like, let us say fx is there, which is 2x plus 3, and a function gx is there, which is log x to the base e, and hx is x cube. Always increase with increase in the input value of the independent variable in their entire domain. That is, graph of the function rises from left to right. So in this cases, graph rises from left to right every time. Okay, or we can say it increases. The function is every time increasing function. The graph the graph rises from left to right. The second part is now functions like fx is equal to cos inverse x. Let us say any other function like gx is equal to 0.5 to the power of x. Always decrease with increase in the value of x. So this decreases graph. So here graph, so since it decreases with the increase in the value of x, graph goes down with goes down from left to right, from left to right, obviously left to right, or increases. Here I will just write increases with x is increasing, and here decreases with x is increasing. So in both the cases the things are different. Okay, now these above functions will be called as monotonic. Both of the above categories, both above examples are called monotonic functions, because they perform a particular behavior. There is a specific behavior. With increase in value of x, the function will increase, value will increase, or it will go from it rises from left to right, or otherwise it decreases from with the increase in value of x. We are very clear what will happen in that case. That's why it is called as monotonic functions. Okay, now let us say functions like fx is equal to x square minus x plus 1 and let us say one more function, that is gx is equal to sine x, has above functions here. Above functions have dual nature, have dual nature, have dual nature, that is increase in some intervals and decrease in some other intervals. That is increase in some intervals, and decrease in some other intervals. Such functions are called as functions are called as non-monotonic function. Such functions have, so one more condition, that such functions have turning points on the graph, have turning points on the graph, and give point of maxima and minima. Obviously the minimum and the maximum point. Now obviously we'll classify the functions as increasing function. Functions of classification of functions we'll do on the basis of monotonicity. It is one increasing function, strictly increasing function, decreasing function, strictly decreasing function. These are the categories on which we will classify the functions. Also we'll discuss about nature of composite function, monotonic function separately again, non-monotonic function separately again, what is the critical point, applications of monotonicity, finding range of the function and number of roots of the equation using monotonicity, proving inequalities using monotonicity, concavity of curve and point of inflection. So these are the topics we'll start to study. And point of inflection, that is an important point. Maxima and minima of a function. Identify maxima minima by checking value of function in the neighborhood point of extrema. Second derivative test for maxima minima of differentiable function. First derivative test for maxima minima of differentiable function. Test for maxima minima of discontinuous and non-differentiable functions. Global absolute maxima and minima, global maximum and minimum in A, B, global maximum minimum in A, B, application of extrema in curve tracing and analyzing root of equation, number of roots of the cubic equation, application of extrema in optimization, plane geometry and coordinate geometry, application of extrema in solid geometry. So these are the concepts we'll try to study in this particular chapter. Okay, so these are the important topics we'll try to understand classification is one of the important points to understand. Okay, so it is a very short lecture, I'll say. We'll start this in detail after the initiation of the next class, right?